Graphs of inverses. So, to find an inverse of a function, if you're given a table, okay, what we want to do is, it says plot the points from table 1 on the graph. So we're going to start off by plotting these points. Okay, so you may want to pause the video and plot these points. Switch the x and y coordinates. Now this is the key to finding the inverse of a function. We want to switch the x and y coordinates. So x is -2, that becomes our y coordinate. Y is 0.25, that becomes our x coordinate. Let's switch all of them. Okay, so we have them switched. Then it says plot the points from table 2. So we go ahead and plot those points. You may want to pause the video while you do that. Okay, now it says draw the line y equals x on the graph. Okay, so here's the line y equals x. Remember that is the parent for the linear functions, y equals x. Okay, now it says look for patterns. So notice this was our original function. We switched the x and the y and then we replotted the points. This represents the inverse of the function. This is the original and this is the inverse. So what patterns do you see? Any patterns you see, go ahead and write down anything that you see right here in this blank. Okay. And actually, I'm sorry, down here at the bottom, go ahead and write down what patterns you see down here at the bottom. Okay. Now example 2, same as example 1. Go ahead and stop the video, fill in the table, graph both tables, and the line y equals x. And hint, what do we call this line? What's its relationship to the two functions? Okay? So please do example 2, write down any patterns that you observe. When two graphs are reflections of each other over the line y equals x, then they are said to be inverses of each other. To find the equation of the inverse, we start off by switching the x and the y in the equation and solving for y. This is extremely important that you remember how to find an inverse. So let's take a look at number 1. It says write the equation for the inverse of each of the following relations. So first of all, we have this function. It's a linear function because the degree of this polynomial is a 1, x to the first power, so it is linear. We're going to start by switching the x and the y. So we literally switch the x and the y. Notice they switched places. Next it says solve for y. So we're going to solve for y. So we're going to go ahead and isolate the y by subtracting 8 on both sides. We get x minus 8 equals 4y. Then we undo multiplying with dividing. So we're going to divide both sides by 4. So we get 1/4 x minus 2. Because this is a 1. 1 over 4 is 1/4. 8 over 4 is 2. So this function here, which is also what type of function? Linear, is the inverse of this function. And so to show that, we put a -1 in the exponent. This means inverse. not just inverse, but it also means it's the inverse of function y. What's function y? Right up here. This was the original function. This is the inverse function. Using function notation, we might have had f of x up here equals 4x plus 8. Showing the inverse of using function notation, we would have f of negative 1 of x equals 1/4 x minus 2. Original function, inverse function. Okay? And here we have one in function notation. So what we want to do, remember f of x is the same as y. And so when we do this problem, we want to use a y instead of f of x. Okay, we switch the x and the y. And then we solve for y. So again, isolating the y. Canceling out the negative 5. Okay, this is the inverse function now. So we get 1 over negative 5, so that's negative 1/5 x. And then a negative divided by a negative is a positive, so we get a positive 7/5. Leave it as a fraction, please. Don't change it to a decimal. Since we were in function notation, let's write our answer in function notation. So the inverse of function f, the inverse, is negative 1/5 x plus 7/5. Okay, let's take a look at number 5. Again, we're going to switch the x and the y. Please remember that step. Please remember, to find the inverse, we switch the x and the y. Everything else stays where it is. Okay, solving for y, we're going to go ahead and undo the minus 6 with add 6. Undo the multiply with divide. And then we have to undo the squaring. So let's take a look what we have here. We have 1 over 8 x plus 6 over 8 equals y squared. Now this looks like it's going to get a little bit messy, because to undo a square, we have to square root, which means we're going to have to square root both of these. So we're going to square root both sides. And that's going to look a little bit messy here. It's the inverse function, and let's just go ahead and leave it like that. Let's not even attempt to make this look prettier. 6 eighths reduces to 3/4. We'll go ahead and leave it like that. Kind of crazy. But notice that our original function was what type? Quadratic. Notice our inverse function. Quadratic became a square root function. Is that true for all quadratics, do you think? Do all quadratics have inverses that are square root functions? Think about that. Is that true? And what about up here? Our original function was linear. Our inverse was linear. Is that true for all linear functions? What do you think? Yes or no? Let's take a look at number 6. It says write the equation of the inverse and then graph the following relation and its inverse on the same set of axes. Okay, let's do this real quick here. So for review, we start off with the y-intercept. Then we apply the slope. We want to put it into rise over run, so rise 2, run 1. Let's go ahead and draw this line since we know that it is linear. Okay. All right, now let's get the inverse function. What's the first step? Do you have it memorized yet? Switch the x and the y. What's the second step? Solve for y. So our inverse is going to be 1/2 x minus 2 equals, don't forget the inverse notation. Okay? Let's go ahead and graph this one. Let's use a different color. We got a y-intercept of -2 and a rise and run of 1 and 2, so rise 1, run 2. Alright, let's go ahead and draw that. That's going to be this, the inverse function. Notice the original was linear and the inverse is also linear. Alright, now let's go ahead and put in the y equals x. Interesting. Interesting. Do you notice anything? What is this line called? What is this line called? Is the relation a function? So is the original relation a function? What do you think? I hope you said yes. Is the inverse a function? What do you think? I hope you said yes. Okay. So let's go on to number 7. Running out of time here. Please go ahead and do number 7 on your own. And turn the page for me. It says there is a way to tell if the inverse is a function by looking at the graph of the relation. It is called the horizontal line test. Okay? Do you remember the vertical line test? Remember, the vertical line test determines whether or not a relation is a function. Okay? Now, if it passes the horizontal line test, then we know that the relation has an inverse. We will continue talking about this on the next video. See you guys tomorrow in class.